धीरं कृतकृत्यं चडुलं स्फुटतर निपुणं कर्मं പാടാമേ നാടിൻ കാവൽ സംഗീതം നേടാം നന്മതൻ സ്നേഹം സന്തോഷം തേടാമെന്നെന്നും ശാന്തിതൻ സന്ദേശം ചേരാമേരെന്റെ ലോകം കണ്ടെത്താൻ സത്യം പാലിക്കാൻ നിത്യം രക്ഷിക്കാൻ നിൽക്കുമ്പോൾ മൃദുഭാവം ദൃഢകൃത്യം ഇത് സേന നമ്മുടെ സേന കഠിനം ചലനം മൃദുമൃദുരം പ്രിയവചനം
ഞങ്ങൾക്കും നിങ്ങളാശ്രയം എന്നെന്നും നൽകും സാന്ത്വനം വഴികാട്ടുവാൻ ജനമൈത്രിയായി
കയ്യെത്തും ദൂരത്തെ സേന എന്നെഞ്ചിൻ കാവൽ സേന ശാന്തിരതം ഭയഭയരഹിതം ധീരം കൃതകൃത്യം ചടുലം സ്ഫുടതര നിപുണം കർമ്മം അതിശക്താനിപുണം സ്വയം നിജഹൃദയം കഠിനം ചലനം മൃദുമൃദുരം പ്രിയവചനം ശാന്തിരതം ഭയഭയരഹിതം ധീരം കൃതകൃത്യം ചടുലം സ്ഫുടതര നിപുണം കർമ്മം നമ്മുടെ സേന.
Hello and welcome to all joining us here today. I'm Meera Jaydevan, a member of the organizing team here at Hackbee 2021. The Kerala Police Cyberdome brings forth the 5th edition of Hackathon, Hackbee 2021, with a theme on demystifying the dark web. This time also we have organized a series of tech talks which would be beneficial for the tech people as well as others. Before we begin, let's take this opportunity to thank our pillars of support. We have Beagle Security as our technology partner, Cloud4C as our cloud partner, Mashup Stack as our knowledge partner, Ecolib 360 as our sustainability partner, and Federal Bank and ICICI as our banking partners. Our community partners include ICMEC, OWASP, Voices India Affiliate, ASRG, Isaka Trivandrum Chapter, Nalcon, GTech ATFG, and AWS User Group Kochi. We would also like to thank our partners, BeSafe, CloudSec, and vConsole. Thank you all for the support shown in organizing Hackbee. Joining us today to enlighten us on the topic, Design Principles to Strengthen Security of Your AWS Cloud Workload, is Ms. Rohini Gaunkar. She is a Senior Developer Advocate at Amazon Web Services, and AWS User Group Kochi is one of our community partners. She has over a decade of experience in the IT industry, primarily focusing on cloud computing technologies. With AWS, Since January 2014, she has worked on multiple roles, including being a solutions architect in ASEAN and India. She has been leading conversations with businesses of all industries and sizes on innovation as they deploy critical workloads onto the cloud. She is passionate about sharing her experiences on building architectures with best practices and helping strengthen the builders of tomorrow. She also frequently speaks at conferences, community meetups, online events, and is also a mentor for aspiring women in tech. Thank you, Rohini, for taking the time to be with us today.
Thank you
Before
so
I
much.
Thank you. Before I hand over to you, I would like to let the audience know that they can drop in their queries in the comments section on the Hackpeace Facebook and YouTube channels, and we'll be responding to the queries at the end of the session. So, with that, I invite Rohini to begin today's session.
Thank you, Meera. Thank you for inviting me. And thank you, everyone who has joined the streams right now. Thank you so much for joining in so late on a Friday evening. But I hope I make this more interesting for you, and let's start learning. So, let me share my screen quickly. Can you share my screen? Awesome. So that's the topic for today. That is design principles to strengthen the security of your AWS workload. Uh, my name is Rohini. You can reach out to me on these channels, on LinkedIn, on Twitter. I do have my own YouTube channel as well. And I do some coding here and there. So I have my GitHub page as well. So, what are we going to talk about today? We're going to talk about AWS Cloud in general, because I do want to set a little bit of stage about what AWS Cloud is. I do want to talk a little bit about what security means in the AWS Cloud. What are the different design principles to look for? We will also look at some of the demos, and we will know what more to learn for. So before we begin, I do want to give a quick insight about who am I. So I am Rohini, as Meera mentioned, I have been in the industry for more than a decade. I've been with AWS for last 7.5 years, and I've done multiple roles in different countries. So that's a little snapshot of who I am. And I've talked to a lot of customers, majority as a solutions architect. So all the things that I'm going to talk about, and there's more, obviously, but I'm going to try and squeeze in whatever I can in an hour. So hopefully you will enjoy this session as well. So that's about me. So what I would want all of you to do is go to slido.com and go to enter the code 403403. And I do want to know a little bit about you. Who are you in the audience? And uh, I want to know a little bit about you, so that I can tune in my session a little bit to meet majority of you. So just go to slido.com and key in 403403. Okay, and I'll just start the poll as well, as most of you are going in, just to see if someone is giving in the input. I hope there are people in the audience right now who are listening to this. Otherwise, we'll get back to the session, and we'll see it later. So yes, there are people in the audience, so thank you for that. We'll just wait for it to go maybe till 5. Hopefully we'll give people some time. Okay, let me also start the other questions. So there are two more questions. What role best describes you? Who are you? Are you a student? Are you an engineer? If there are multiple things that, like you are a student, but you're also into development, do take two at a time. Awesome. Okay. I may have missed out something there. So if that is the case, just add in other. And do you use AWS today? Because that's something that I'm going to talk about. So I do want to understand about your AWS usage, how about your AWS knowledge as well. Awesome. So using AWS for more than 6 months, that's awesome. And there are few people who are not using AWS today. So hopefully I'll level set a little bit and get the answers. Mira, can you just make my screen share a little bit bigger than me? It's okay if I'm not big on the screen. Awesome. Thank you so much. So yes, so a lot of you are exploring AWS, have been using AWS for last 6 months. And there are some who have not used AWS. So hopefully I'll level set a little bit for you. So without wasting more time, thank you for giving your inputs as well. I will look at it on the side as well. So let's begin. Get ready to type in your comment section. Okay, wherever you are coming in from, get ready to type in your comment section. I will ask you a question and you have to write an answer to that question. And what you do is, once you write that answer, if your answer is correct, and hopefully I will get many responses, so any first or second correct answers, I will be giving them some AWS credit. So you just connect with me on LinkedIn or on Twitter, send me the screenshot, and I will give you some AWS credits. Okay, so get ready to type. 1, 2, 3. So what does the HTTP status code 403 stand for? We just added that in the slido.com, and these questions are very simple for most of you who are into security business. So what does HTTP status code 40 stand for? And I'll wait for 3 seconds. So the answer is obviously forbidden, right? HTTP status code 403 stands for forbidden. So if you have given the right answer, take a screenshot and just send it to me on LinkedIn or on Twitter. Awesome. So let's talk about cloud computing. To some, cloud computing is simply a data center somewhere, simply a place where there are a lot of servers and there are a lot of racks. It's just about infrastructure, and cloud is just for people who want infrastructure. But that is how it began initially. But over the time, I think cloud has evolved a lot. Cloud is everywhere. Cloud is in the applications that you have been using. Cloud is in the devices that we have been using. Cloud is even the way we are doing our grocery shopping. We are using cloud in some way or the other. And I will show you a little bit on how people are using cloud today. But the idea is, when initially cloud came into place, people had doubts about cloud. Is cloud secure? Is cloud for me? Is it cloud for everyone? But now cloud is the new normal. And this is true because now almost all the applications, most of the applications that we see are using cloud in some form or the other. So you're not someone that's saying, hey, I don't use anything with cloud. If you're using any social media websites, if you're using any games, if you're using any streaming applications or your OTT applications, they are using cloud computing in the backend. And that is what AWS does. AWS is a cloud computing platform, and it is Amazon Web Services. Okay, and this AWS provides a broad and a deep platform. So broad as in it provides a lot of different things, and it is deep in a way that it has depth in a lot of different things that it does, and it helps customers build sophisticated, scalable, and secure applications. And that is what we are going to be focusing on today, a little bit about secure applications. So AWS helps customers build these sophisticated applications. AWS provides these resources, which are IT resources like compute, your networking, your databases, all these different kind of resources. And we'll see some of these resources to customers, and customers can access these over the internet or over some kind of direct connect lines that they have purchased. They can access these, they can work on these, they can create beautiful applications that ultimately the end users, that is us, can use them. So a lot of customers do use AWS, and there's like millions and millions of customers that use AWS today. From startups to enterprises to a lot of public sector projects are run on the AWS platform. There are also a lot of service-based industries that are using AWS for their end customers, and there are finally a lot of ISVs or a lot of software vendors that are using AWS for creating and running their projects. So why do customers choose AWS? So this is just a little bit quick insight. The first thing, cloud got in something is an ability to experiment, an ability to innovate. Before cloud came into place, people couldn't experiment that quickly as they could. They would have to spend so much money, to invest so much money into getting those servers, building a data center, providing security for it, providing people for it, right? Now with cloud computing, you don't have to worry about a lot of those things. All you have to worry about is your idea, experiment on your idea, create innovative stuff. And that is what we have seen with a lot of startups coming up after cloud computing came into place. Because now startups had a place to go and experiment, to go and play, to go and see, hey, does this work for me or not? If it doesn't work, I'm just scrapping it out and going on to my next idea. I don't have to worry about, acha, where is this servers going to come in, how many months it's going to take in, how long it's going to be to install these things. Of course, then there came cost savings, because now you moved from your capex to your operational expense kind of a discussion. And cloud will charge you something like only pay for what you use. So it's like electricity that we're using today, right? The you switch on a button, you start charging your mobile. The more your mobile is going to be charged, that's how the meter in your house is going to keep running, and you're going to get some meter reading, and you will be charged based on that meter reading, right? Similarly, it's what it is in cloud. You only pay for what you use. There are lower upfront expenses as you move to OpEx. There's a lot of elasticity. Now, cloud is virtually unlimited. Okay, notice that, virtually unlimited. People say cloud is unlimited, but I would say it's virtually unlimited. There are always some kind of limits whenever it comes, but you don't have to guess capacity. If I want one machine today, or I want 10 machines today, I can pick them and start them up within minutes. I don't have to worry about guessing capacity. If it goes into thousands and 10,000s and lakhs, that's a different story. But if you're talking about even from 1 to 1,000 virtual machines today, that is something that is virtually possible with cloud computing. You can innovate faster. We already talked about it, how startups have become the differentiators in the market when it was about cloud computing. Go global in minutes, we will also little touch base on that. But because of the way that cloud computing or cloud vendors have created these different infrastructure across the globe, and you all have to do is sit at home and access it over an internet. Now you can go global in minutes. I can sit in India and run my business that is in US. As an example, I don't have a business, but I can run a business in US using the data centers in US itself. Or if I'm sitting in US, I want to start a business in India, I can still use the data centers in India and run the business in India itself. So you can go global in minutes. And of course, AWS has a lot of service breadth and depth, which we will look at in a minute. So when cloud started, and when AWS started in 2006, when it was launched, initially we only had 4 regions across the world. But as you can see that the demand for cloud computing increased, or demand for AWS increased, we started adding more and more regions across the world. Regions are nothing but locations that AWS has its own data centers. And we'll dive a little bit onto what regions are and what and why and everything. So over the time we saw a lot more, and just within last from 2016 to 2020, last 5 years, we saw 14 more regions come into AWS cloud. You can see that in India we have a region in Mumbai. So we have something that is local to us in Mumbai, and there is second region that is announced, that is to come in the next 1 year or two, that is in Hyderabad itself. But we can still host our cloud applications anywhere across the world. But if you have applications that need to have data stored locally, that need to adhere to our Indian government's local data privacy guidelines, or you have to meet that, then you have to store it in Mumbai. But otherwise, you're free to use any in the world. So this can be a little overwhelming, so stay with me. Don't get worried about, okay, what is she talking about? Why are there so many icons? And if you can't even read them, that's fine, because these are just some of the categories of things or categories of services AWS has today, right? These are some of the things that AWS provides, and this is not an exhaustive list. So when you have to start looking at this list, how do you look at it? One is you look at the red pointer, right? The base is the infrastructure. Where is cloud located? Which country it is located? The max you would know which city it is located. If you ask me that, hey Rohini, you're an AWS employee, do you know where the cloud is in AWS data center is in India? Sorry, I don't know that. Because, and I'm not lying, because that is how the company is. That is a very confidential information that even the employees are not aware of. People who may be working in data center, even those would have different levels of security as to who should know this kind of information on this confidential information. So to be honest, no one knows where cloud is in India, but it is in Mumbai, and that is being certified and audited by third party regulators. So we are not lying about that, right? So that is the base infrastructure. Then you have the core services like compute, like creating virtual machines in the cloud. You can get storage, you can get database, you can get on networking. So these are the base core services. If you want to learn about AWS, there are 100 ways to learn about AWS. There are 100 ways to interact with AWS. My favorite way is to know the basics. Always, like, I have this mind that I should know the basics before I jump into something high, so that I don't miss out on the basics itself. So know these core services, these are your basics. And you can see security is also something that is on the bottom, because security is very, very important. We will talk about security in this session, so I'm going to skip that. But then there are all other kind of services, or all other kind of tools on AWS for DevOps, for analytics, for mobile services, for machine learning and artificial intelligence, to IoT and whatnot. So there are a lot of services on AWS that can support some or the other use case. And how do customers use these? Think of it like a Lego block, right? You pick and choose different services. You make some kind of architecture from these services, and you use that. There is no right way or there is no wrong way. There is just the customer way of doing things. So security is the top priority, and Vanu Vogels is our CTO for AWS, and he says this, that protecting your customers should always be your number one priority, and this is our top priority, that is security. So that's why, as a solution architect, even if I'm not a security specialist, I still need to know the basics of security on the AWS platform. I still need to guide a lot of my customers on security. We do have security specialists, we do have a lot of people who focus on security, but it is everyone's responsibility to ensure that our customers have build trust with our customers, with the platform itself. So if I have to categorize AWS services, these are the main AWS services for security, identity, and compliance solutions. These are the main categories. I'm not going to bore you with a lot of these services. We're just going to look at maybe two major services from AWS for infrastructure protection and identity and access management. But that doesn't mean that there are not other solutions on the AWS platform. So if you are into security and you're interested to see how to do these things, there are a lot of things to do, and just don't rely on the session today. On the AWS platform, we do inherit global security and compliance controls. So there are a lot of different laws and regulations and a lot of different frameworks that we support on the AWS platform. This is not an exhaustive list that you see on the screen. There is also an India-based white paper or compliance documents that we have. You can access those if you are interested. I've provided the link below. Don't worry, I will also tell you how to access these slides later on, so you can get these links then as well. We do have large ecosystem of security partners. If AWS doesn't have a product that you need, you want, for example, antivirus solutions. If we don't give antivirus solutions, that is not our base core business, right? But it is for someone else. So you can use those solutions onto the AWS platform as well. So that is how the platform is very flexible, that you can use any third-party solutions on the AWS platform today. And these are some who have direct integration, who have direct integration to work with AWS. So this is just one use case or one case study that I wanted to show, because a lot of times finance is something that needs to have a lot of security, right? I mean, if I have to compare, then financial data or financial information should have the utmost security. So when a CISO of a company like FINRA says that, I've come to realize that even as a small organization, we can be far more secure in the AWS cloud. and achieve a higher level of assurance at much lower cost is something that they appreciate. And that is what we ask our customers as well to look for, that if you have to invest in so many things, just to consider investing in physical security of your data centers. Imagine the amount of security policies that AWS has on the AWS platform, and for you to go ahead and do that for your own small business, it's a overkill, right? So you can still use the tools that AWS has created, and we will talk about those, but it's an overkill because in a traditional environment, a customer has to be responsible for everything from physical hardware to the software layer to the customer data that they're working with. Everything is your responsibility. I mean, if you are someone who is building applications, if you are in a traditional on premises and you have your own data center, this is your responsibility. And it's a lot of things to look for aside from your actual business that is going to generate you revenue, not this, right? So when we talk about AWS, we look at it as a shared responsibility model. So it is shared security responsibility model that AWS follows. What does it mean? AWS is responsible for the security of the cloud. Okay, AWS is responsible security of the cloud. So it is responsible of the global infrastructure, the regions and availability zones, and the compute and the storage and everything that AWS is providing. AWS is responsible for that. You as a customer is responsible for security in the cloud. That means whatever you're hosting on the AWS platform, that is something that you're responsible for. Now a lot of people will be like, oh, so AWS is saying that, hey, we are not responsible, you put data on cloud, so we are not responsible. It is not what that is meaning. What it means is that on the AWS platform, we give you a lot of different tools, we give you a lot of different options, but to select these different options is something that you have to do. See, because if you consider AWS, we have millions of customers. A customer could be a student who doesn't care about security at all. He just wants to play and learn cloud or want to try few items, to someone who an enterprise customer or a finance customer who has highest level of security requirements, right? So if we are in between, we have to work with this level of variety of customers, then we have to give them the options to do it on themselves. A student may not be interested in having that kind of security that an enterprise may have, but we should give options to both, right, to select what they want to do. And that is where that shared responsibility comes in, that AWS will take care of the base, but you have to take care of the data that you're putting on the AWS platform. And this changes a little bit, and we'll look at that as well. So when you're, for example, you're hosting like a PCI or a HIPAA compliant application on the AWS platform, your audit team will look at your data. So you will have to have an audit team that will ensure that your data, your customer section, is PCI and HIPAA compliant as well. AWS services are PCI and HIPAA compliant, yes, but hosting so application on AWS doesn't make it automatically compliant. You have to work with your audit teams, you have to work with them to make it more compliant for that compliance. Sounds good? So that's what I said. When it talks about infrastructure, AWS takes responsibility up to the foundational services, the compute, the storage, the database, and networking. But most of the responsibility of the content, the data from the operating system up, is something that you are responsible for when you just use the infrastructure services from AWS. As we move on to using something called as managed services from AWS, this responsibility starts shifting. So when we talk about managed services, where we give you a platform and you bring a container based, for example, a container based application onto AWS, your responsibility section reduces, but our responsibility becomes bigger, because now we are giving you that platform to host these containers, right? So up till that platform is something that we take care of from a security perspective. And as further you start using more abstracted services, if you have used AWS, you may have heard something like serverless. So when serverless doesn't mean there are no servers, there are servers, but those are AWS's responsibility. You are worried about your content, about your data, about your client side encryption, which we cannot take care of. But most of the other aspects is something that we take care of. So that is very important to understand, because at a glance, you can see that the line varies from where we are and how this responsibility between AWS and you shifts. So the more abstracted services you use, the better best practices are built in, and it becomes less of a responsibility of yours to ensure there is security. But you also have options to use infrastructure services, where if you want more customization, you want more control, then you would go with the infrastructure services. So let's talk about the main topic, that is design principles. There are few design principles that I've picked up. I will not be going through all of them. I'll just go through two because they are design principles and they are very much in depth, but we'll try to make it a bit simple and we'll try to learn at least a couple of them. So the two that we're going to cover today is applying security at all layers in AWS, and the second is implementing a strong identity foundation. The others we will talk about a little bit when the time comes. So the first thing, applying security at all layers. Most of you may be from a security background or defense background, so you may know something called as defense in depth DID approach, and you can apply the same principle here in the AWS or in the cloud environment. So let's take an example. Have you been to a fort or a castle? Most of us have, because we have so many forts in India that we can visit, right? And or if you have not visited, but you may have seen something in movies as well, Lord of the Rings or any other movies that you may have watched, you may have seen there are different layers, right? First layer is there, the enemy tears that down. There's a second layer that we have. There may be a crossbow, and then we have the people who are on horses. So there are different layers of defense that we keep when we are talking about these environments. And if I have to talk about modern times, in modern times you could have houses, right? Most of us, like I live in an apartment, no one can come to my bedroom. My bedroom is a very private space for me. No one can directly come to my bedroom. First they will have to come to maybe my building gate, my main gate for my building. Then there's a security sitting at my society lobby. Then I have security at the door, right? We have video cameras at the door. There's a main door for my house. Then there is a living space, which is maybe a public space. If someone wants to come in, they can be in the public space. And only after someone can go into the private space is after crossing the bedroom door, right? So we have these different layers. We also have different guardrails on our windows so that no one enters in or no one actually even goes out, right? But you have different guardrails, you have different layers in your real life, and that is how you think about when you think in cloud computing as well. You have to have these different layers. So if someone is trying to break in, has to go through so many layers, and by then hopefully you've got it, or people are not able to break those layers. So when you talk about these different regions or these different locations across the world, it's not just one data center. Okay, regions are made of something called as availability zone. So you can see on the screen, regions are made of availability zone. I would say, what is an availability zone? If you're new to cloud, availability zone is made up of multiple data centers. So 2 or more data centers make up an availability zone. 2 or more availability zones make up a region. Okay, so by default, AWS will always have 2 or more availability zones across its regions, and that way we have so many regions across the world. It's 25, 26. I'm sorry, the number keeps changing, but there are so many regions across the world. So why is this required? First is, these data centers have one or more redundant power supplies. They will have redundant internet access. They will be housed in separate facilities. So there is some problem in one of the availability zones or one of the data centers, it should not go and affect the customers in the other availability zone or other data center. And this is a best practice, that whenever you're hosting applications on AWS, always think about multi-availability zone. Never put all your eggs in one basket. Put them maybe 50-50 in two. So even if AWS availability zone, even after having so much of redundancy, has an issue, I mean, we cannot stop floods, right? We are not God in that sense. So there are, if one of the availability zone has some issue, some kind of issue, that application will still keep running from the second availability zone. Even if it's 50% degraded, you can still extend or scale in the other availability zone and you can continue working. So always think multi-availability zone. The second is the networking layers. Now, stick with me because there is a lot of built up in the architectures. So you will have to look at the screen. Don't miss out on what I'm talking about here. The first is there's a service called as Amazon Virtual Private Cloud. Okay. What does it mean? Virtual, that is logical, and private means isolated. So it's your own logically isolated cloud in the AWS cloud. Okay, so that's as simple as I can put. Before VPC came in, everything was public. So whatever you create in AWS, let's say you create a virtual machine, it will be always accessible for everyone in the world, unless, I mean, there are some firewall rules, but otherwise it could be accessible from anywhere. And I started working with AWS technology since VPC was launched. So VPC is a game changer. It is a logical isolation or a logical cloud in the AWS cloud, just for you. How do you create this? You provide something called as a CIDR. Okay, a CIDR is simple. It's something similar to an IP address, but additionally, it also has this number after a slash that is called as a IP network prefix. Now, this is not a networking session, but think of this as the way it can create an IP range. Okay, so you provide this, and what happens is you provide a VPC with an CIDR IP. So when you provide this, this is the IP range. This denotes this IP range. So all these IPs can be assigned to the virtual machines, to the resources that you keep create in AWS cloud. So with this VPC, you can create so many of instances or virtual machines or resources in the AWS cloud. So what you do is when you create this VPC, you can create then something called as subnets. Now, if you have worked in data centers, you would know that you had DMZs and you have to create these different sections of your network. That's the same thing. So you called it as subnet, and you create these different subnets as a subsection of this VPC. Okay, so you create something like a VPC, which is a big network, and then you create small subnets out of that. And when you're talking about different layers, you define these different subnets based on your requirements. These are different subnets with different IP addresses, IP space. So a subnet could be just a public subnet, a subnet where anyone from the internet can access it, or this subnet can go out. Okay, so a public subnet is the only place someone can come in. Everything else you can then demarcate specifically. Okay, these subnets are going to be just for databases. These subnets are going to be for my web applications. Like Aurora is one of our database services. So this could be for databases. This could be for virtual machines. This could be for a NAT gateway. When you create these subnets in AWS, there is no way of saying, actually, this is public subnet, and it goes and creates a public subnet. That is not how it works. The way it works is using route tables. So you define in the route table as to what happens. So let's say this route table has 0.0.0/0. That means anything to the internet can be accessed via something called as an internet gateway. That IGW is internet gateway, which you can create in AWS. So using route tables, you can create different kind of subnets, and it is a best practice. I've seen so many customers dumping everything into this public subnet, which is a very bad practice. Having layers is the first step to do it well. So how would you do this in the AWS cloud? The first thing is, in the AWS cloud, you create an account, you figure out which region do you want to work with. Let's say we are working in Mumbai region. Okay, then you would have these availability zones. Remember I said 2 availability zones, multi-AZ. That's how you have to think. Then you create something called as a VPC that we just saw. So in VPC, I've given this CIDR block. Okay, now once you created the VPC, you would define, and this is just for an example, but you should have more than these for sure. But you would have public subnet. Now subnets are availability zone specific. Okay, so you create one subnet here, you create another subnet here. See, the IP space is different. 2 public subnets. I have 2 private subnets. Okay, I created 4 subnets in the VPC. Now you create, now this is just a symbol for a virtual machine. Okay, now let's say you create a virtual machine in each subnet, and there is something called a security group. We will look at security group in the next slide, so don't worry about it completely. What by default, what will happen is this will have a local route. Look at the IP space, 10.0.0/16 local. What is 10.0.0/16? This one. So what it means is the subnets can talk to each other locally. So that's the one route that is available by default. So everyone can talk to each other locally within the cloud itself. With me so far? Then you create something called as an internet gateway. What is an internet gateway? An internet gateway is something that allows these virtual machines to be accessed from outside. And that's what you add in the route. You add in the route that 0.0.0 goes via the internet gateway. So if you are a cloud admin, if you are an administrator who wants to access this virtual machine, you can easily do that as long as there is an internet gateway and you are accessing over an internet. Okay. But can you access this virtual machine who's sitting in a private cloud? There is nothing in the routes. Can I access this virtual machine? No, because it's in private, there is no internet route. So how do I access this virtual machine? How do I get access to this instance? Easy. What you do is let's call this virtual machine as a Bastion host or a jump server. These are some of the terms that we used to use when we wanted to jump from one machine to another. So what you do is, first, you access the Bastion host using the public route, and from the Bastion host, you can jump into the other one. So only people who have access to this can access this. Otherwise, this is not accessible. Okay, the one in the private subnet is not accessible. Okay, so can this go out to the internet? Now you would say, what is the requirement for this to go out? You're using Windows. Let's say this is a Windows virtual machine. You want to go and update your Windows updates or install your Windows updates. How would you do that if this one has no route to the internet? There is something called as Nat Gateways. Now, NAT is a full form of Network Address Translation. So it's a NAT gateway. What it does, very simple. This one can go out only via the NAT gateway. Okay, so there's only outgoing via the NAT gateway. The NAT gateway will now go via the internet gateway. Now, this has changed a little bit recently, but I don't want to confuse a lot of you who already know how this works. So let's stick to that basic. But this has changed. You don't need to have an internet gateway. You could also have your local company. It could go via your company's network as well. So now that we saw that, let's take a little step back and understand the different firewalls that AWS provides. And some of these are free. 2 are free, 2 are chargeable. Okay. So let's say you have a web server and a database. Now, EC2 is the name of AWS compute service. RDS is name of AWS's database service. We're not learning that today, so ignore that. But it's web and database. Then you would have a web security group and a database security group. And all this I'm showing is a best practice. I've seen a lot of customers throwing everything into one security group. We'll like, what is security group? Security group is a stateful firewall that you can create outside the instances. You don't need to log into the instance and create, like you used to do IP tables, right? You don't need to do that. You can create security groups outside. It's like a box outside your virtual machines, and your virtual machines can have access to these different security groups. So now EC2, it's at an instance level, so it is closer to your resources. It is stateful. If you know what is stateful and stateless, if you don't know, just type in, but you should hopefully know what is stateful and stateless. Stateful, as in, to keep it simple, it remembers the connection request. So anything coming in, it remembers, okay, this guy came in, now it wants to go back with the response, will allow that. But stateless is anyone coming in should also be explicitly allowed to go back. So a request that comes in should be allowed to explicitly go back as a response. All ingress and egress flows at the instance level. It is an L4. So if some of you are students, do study your OSI layer, because this sits on an level 4 of your OSI layer. Then you can also configure IP port protocol. We'll look at it in the demo, so don't worry. The default behavior, by default, you have everything blocked. So you have to explicitly say that open this particular port, open TCP port 80 on this particular virtual machine. So once you do that, only both of these should be able to talk. As a best practice, only the web should be able to talk to database and no one else. On, let's say this is MySQL on port 3306, only web should be able to talk to the database. We'll see that in the demo. Then we already saw, right, there's a public subnet, private subnet. So let's say these sit in the public and private subnet. Now, this instance can be accessed over the internet. We already saw that, right? This is a web machine and someone can access the web application on it, let's say on port 80 via the internet. Okay, so far with me. Now there is another layer of control that is called as network access control list, and it is called as NACL in short, but it is network access control list. And this is at the subnet level, not at the virtual machine level, but at the subnet level. So a subnet can have thousands of machines, right? Or depending on the IP addresses, it has 200 plus machines in it. So a NACL applies at the subnet level, not at the individual machine level. And what it is, it's a stateless firewall, and it allows, it is at the level 3, not at layer 3, not at the layer 4, but it's at the layer 3. By default, it allows everything. So where is this useful? Let's say someone is attacking your virtual machine from a specific IP address, and you want to block that specific IP address. You can do that at the network ACL. You cannot do that at security group. Security group doesn't let you block something. Everything is default deny. So you cannot block anything. You can only allow things, but you cannot allow a specific IP address, right? So here you will use a NACL where you can allow something, deny something explicitly. Once that is done, let's just fast forward to our VPC and regions. So this is an availability zone, this is in region and availability zone. Awesome. So now you would say, Rohini, this is good, but this is also coming from internet. Is there a way to filter this? There are a lot of tools in the market that do IDS, intrusion detection systems and intrusion prevention systems. There are a lot of tools that you can use even now, but AWS saw that there is a need, that a lot of customers are using these third-party solutions and do want something native. So they can use something called as a network firewall. Now, if you have been using AWS, this is a little bit new to the AWS platform. This is launched a couple of months ago. So do check this out. This is a network firewall that works at layer 3 to layer 7. Depends on what you're using it for. It is chargeable, I think. So do check out the pricing before going and using these. But it can do a lot more than these two. So if you want added filters, additional filters on the traffic that is coming via internet gateway or anywhere else. So there are a lot more use cases, but I'm just sticking to this for everyone on call to understand. Next is, now this is a web app, right? So your application is running on port 80 and your clients are accessing this application on port 80. Awesome. I've seen a lot of people do this. Please don't do that. Don't expose your virtual machines directly to your clients. We don't know who has what kind of intentions. Don't ever expose your virtual machines that has access to your database directly to everyone else. What you should ideally do is have more layers. Remember layers? So what would be your first layer? You could have something like a elastic load balancer. And this hopefully should have its own subnet size, because the load balancer internally scales. So it needs its own 20 plus IP addresses. So you should have something like a load balancer. Now there are different types of load balancer. We are not getting into that, but this should never be exposed directly. You should have ideally an ELB and some kind of CDN provider. This is CloudFront as AWS Content Delivery Network provider. Okay, so clients will access CDN. They will access the URL for CDN. Ideally, it will be, now you would have Route 53 or GoDaddy somewhere to point to this location. So you'd say example.com will come and point to this, not this. This should never be actually in public subnet either. This can be in private subnet. So you would have this, then this, and then this. And you could have firewalls or you could have access policies on each of these different layers. For example, there is something called as AWS WAF. So Web Application Firewall. It's a sandwich between different places, but Web Application Firewall, which can sit here or any other endpoints that you have. And it's a layer 7. So it will only look at HTTPS level ingress only, okay, from the internet. And you can do a lot of different things. You could do SQL injection. There is also some somewhere it also helps with bots. It may not be an end-to-end bot management solution, but you can also check that out. So it helps with a lot of common attacks that you can have on your application layer. So just to summarize, we saw 4 different layers of firewalls in the AWS platform. So I've talked a lot. I think I've talked a lot for a while. So let's go and check out some demos. Don't want you to go into a snooze fest. Awesome. Okay. So let's go here. Okay. So I'm hopefully being logged into my AWS console. So this is the AWS console. I have already logged into my AWS console. It has signed me out, sorry. So I'm just going to use something, and you're not supposed to see this, but sorry, I am in a demo, so let's do this. So we are using an internal SSO to do this. And I've logged in through an internal SSO. I'm not logging in through user ID password. I've already logged in to the AWS console. Now it may seem a little busy, may seem a little difficult for someone who's new. Okay, where is my mouse? Okay, sorry, my mouse keeps acting up. And you can say, I want to create virtual servers in cloud. There are different ways of creating virtual servers. You could create something like Lightsail, which is an easy way of creating virtual servers. But if you are creating production grade applications, then you should ideally go with something like EC2, which is Elastic Compute Cloud on the AWS platform. What you would do here is you would go and click on launch instance. So I'm not created anything. Everything is 0 right now. I'm creating something called as Amazon Linux 2. You also have option of creating Mac OS in some regions, not all the regions. You have Red Hat. Let me show you quickly what all you can create on AWS. So you could create, Amazon has its own Linux. So that is Amazon Linux, CentOS, Debian. You can see Red Hat, you can see Ubuntu, you can see Windows, Mac OS as well. So let's go and create an EC2 instance. Okay. When you select this, this will ask you what should be the size of the virtual machine. Now, this could be how many vCPUs and how much memory you want. As of now, you can select a lot more options are available. You're not getting into all of that. I'm just selecting something that is from free tier. I'm just creating one virtual machine. Here, I've already created a VPC. You can go ahead and create a new VPC using something called as a wizard, or you can use infrastructure as code, which is very easy to do, but let's just show you. So you can launch something like a wizard, and you can say what kind of configuration do you need. Do you need a single subnet? Do you need the public private subnet as we saw in the architecture? Do you need hardware VPN access to your data centers, or do you need some kind of VPN access to your data center? So you can just select that, and it will help you configure the VPC. I've already created it. I've created something called as base dev network. Ignore the name. But what I've done here is I've created two subnets in each availability zone. See, 2A, 2B, 2A, 2B. Is this visible? Let me see if I can zoom in. Okay, so that doesn't zoom in. Sorry for that. But 2A, 2B, 2A, 2B, you can see that. And I've created different subnets. One is for ELBs, load balancers. One is for database. One is for application in each availability zone. So let me do this. Let me, as an example, show you something in the ELB. Okay, let's create something in the public subnet. You can auto assign IP. Use subnet default. It's a subnet. If it's a public subnet that I've named it, but if it's a public subnet, then it will always have an internet gateway. So it will be okay. What I'm going to do here is in this demo is copy this, paste here. And I'm just going to quickly go. I don't want storage. You should ideally add tags. Purpose. Okay, what is the purpose? I'm just going to say live demo. And so I can remember to delete it. And this is the security group that we were talking about. So this is the firewall rules that you can use to control the traffic here. I will create a new one. I don't want to select an existing one. Do I want to select? Okay, I have created something already. Let's create a new one. Okay. Live demo 2 and something live demo 2. And I'm saying that this is a Linux virtual machine. I want to access this Linux virtual machine using SSH. So I'm saying SSH, or I can have custom, or I can say everything, or I can say anything else like HTTP or anything else. Okay, so SSH protocol, what is the IP? What is the address, the source address? Like for me, I would always say my IP. Okay, and it will automatically take the public IP that my ISP is providing, or you could say anywhere in the world. This is a very bad practice, and that's what the warning also says. Opening your port 22 to everyone is a very bad practice. Always keep it to custom or my IP. Right now it's my IP, but you can also give custom IP of, let's say, your network if you're accessing it from corporate, or if you're accessing it from other security groups. For example, I could have a security group for database. You can also mention that security group. So only your web and database can talk to each other and no one else. As of now, let's give it my IP. And you can add more rules as you go. So let's add something like HTTP, which is port 80 and can be accessed from anywhere. I don't mind that. Awesome. I had to do something. 1 second. So I had to go ahead and add something called as a role. I could add it later, but I do want to add it now. This is a role that I have already created. We will look at it in some time, so don't worry. And I'm going to launch it. Now, when I want to launch it, I have two options. Okay. Either I can create a new key pair, and a key pair is a way for you to, there's a public key and private key. Now, most of you are into security, so I'm not going to teach you what that means, but there's a public key and private key, and AWS will give you a private key so that you can access this virtual machine from wherever you are, and no one else can access this virtual machine. This is one of the ways for accessing it. Well, it is not the best way of doing it, but it is one of the ways for accessing it. I've already downloaded this key pair, or if you want, you can just say create a new key pair, and you can just give a name and download it. As of now, I've downloaded it, so I will just acknowledge I've downloaded it. I don't need to. I can also access it without a key pair, and I will show you that. I'm just saying launch instance, and that's it. Now just give it few seconds for it to launch this virtual machine. It is in pending mode. It will do some checks and all. So what I'm going to do is I've not named this instance, right? So this is a public web. Okay. I've given it a public. Wow. Where did the public go? Public web. And what I will do is I will also create something similar to this. Network. Okay, where is that image and template? And I will launch one more like this, but everything is same. Okay, sorry, I need to go here. But instead of the public subnet, let's launch it into a private subnet. Okay, and everything is same. Everything looks same. Review and launch. And this one I will say proceed without key pair. Let's see. Okay, so now both my instances should be running. So let's say running. I want to show you so many others that are not running. So it will take a minute for it to pop up. Now my public web is already running. If I want to see more information of what is happening inside this, I can always go and check out. Okay, the other one is also running. Wow, now both of them have the same name, which is my fault. So let me just quickly see how do I change a name for one of them. It's easier to know because one of them will always have a public IP and a private IP. What did I just do? I created both the same way. I'm sorry, my mistake. Let's see. This is in ELB and this is in private. Why does a private one have a public IP? Something wrong I did in my example, but that's fine. Let's do this. So what I will do is, can everyone see this? Let's go and open this in a new tab. The moment I do this, I have to, by default, it will always think HTTP. So I'm just doing HTTPS. So what I've done, I've used this simple command that I've asked it to create HTTPD and just start it. Okay, install HTTPD and start it. That's all I gave it in its user data. Now, because I have given in the security panel, let's open the security setup. Here, I have allowed it to have 80 from anywhere. So I can open my application on port 80. Right now, there is no key pair, there is no SSL certificate. So it is only available on port 80. Now let's try and connect to this virtual machine. Let's go back and select this virtual machine, connect it. Now there are two ways of doing it. Either I use an SSH client. The way I have downloaded this key pair, I told you I downloaded it. So let's copy this because I've already downloaded it. So I'm just changing its permission. Okay, permission is changed. Just have to copy this. And first time you're accessing it, so it's cool. Permanently added, and I am in that virtual machine. Now I can do whatever I want, CD / or CD, whatever. Where am I right now? Let's just look at it. CD / this is just a normal virtual machine out of Amazon Linux 2. Now I can get in, I can do whatever I want in this virtual machine. Now this is not the best practice. The best practice is to use something like Session Manager or something like EC2 Instance Connect. Let's use Session Manager because it connects to your instance without any SSH keys or having a Bastion host. Remember, I said a Bastion host in my architecture. You don't need a lot of that. Even if it's a private virtual machine, you can access it. The moment I click connect, it will open the session into that virtual machine in a browser based access. You will automatically see that coming up. Okay, great. So this is a normal virtual machine that I just created. Same thing. If I run this command and do that, same thing, but in a browser based access. I didn't have to give any key pair or anything. Now you would ask me, Rohini, do I have to have a browser? I don't want to do this in a browser. I want to do it in my terminal. Can I do that? You can do that with this command. So what you have to do is you have to install AWS CLI, obviously, but you can say AWS EC2 Instance Connect, and you can say instance ID. Go back and copy this instance ID. It's already there on this page as well. So if you want this instance ID, you will just copy that, paste it, and you should be able to access this virtual machine. Something went wrong. Okay. I think I goofed up on the comment. But anyways, so I've given an SSH keeper, so it's crying a bit, but you can also access it via the terminal. Now that I've shown you that you can access this on port 80, I will also show you the beauty of this. Let's go to security groups and edit inbound rules. And let's go ahead and remove these. Okay, I'm just removing the port 80. Now, typically, some other places you would see that it would take a lot of time to apply these rules. But because this is AWS security groups, you can manipulate that easily in a security group and it will automatically stop doing that. It is very instantaneous. That's the fun part of it, that it is very instantaneous. Now, let me do this. Okay. So if I create a private instance, it will not be able to access the. So let's go to networking. Let's go to this. Let me also show you VPC quickly. So this is the security group that I created right now. And if I have to go to route table, you can see that it has a route to 0.0.0. Hopefully, let's see, something went wrong in that networking. Okay, so private app. Did I give a route to internet gateway? It had a route to that gateway. And auto assign no tha, right? So let's do this. Let's again try to do this. Let's try to do this. Launch more like this. And edit instance details. And here, yes, this was incorrect. Use subnet default. So let's give this. By default, it's disabled. Everything else should be okay. Review and launch. And launch. I don't care. I don't care about this. So now this instance, and I will also, let me tell you what I'm doing. Just give me a second. And I'm just going to security groups and I am changing this back to 80. So edit inbound rules. And I'm saying I want to add HTTP. Okay. So from anywhere, IPv4, save rules, all good. Let's see if our website is back to access. Yes, our website is okay. Okay, so I've added the security group rule. Everything is back to working now. But now what I've done is I've also created another instance. And this is the instance that is running. So let's call it private web. Okay, so that's how it should be. This is a private web. Now you would see this one doesn't have IP address because it's in a private subnet. So it doesn't have a public IP address, but it has a private IP address that we provided. And everything else is same. Now, if I have to access this website, so I don't have a public IP, I can just copy, let's say, copy the private IP, go here and say, will this work? This should not work because there is nothing running on that. I mean, there is something running on that instance, but it's IP address. It doesn't have a public IP address that can be used from outside. And even if the port is open for it. So it is using a private IP space. But can I use it from this virtual machine? So let's say I can do curl HTTP. Will this work? This definitely works. Remember why? Because both of your subnets can talk to each other. So this virtual machine that I have already logged in from the public subnet, that can access the private subnet web application, but I cannot access it from my internet. It's still rolling. It is still not accessible. Does that make sense? So when you're creating these different network boundaries, you should make sure that what is publicly will sit in a public subnet, what cannot be accessed publicly should sit in my private subnet itself. So that is how we create these different networking boundaries. I've talked a lot, so let's get rolling. Now get ready to type again. If you are listening to me till now, please stay tuned. I do have few minutes to go and then we'll wrap up soon. But get ready to type an answer for a question and take a screenshot and ping me on LinkedIn or Twitter. Dash is a logically isolated virtual network that you define. What is it called? And give me a full name, okay? Don't give me just keyword or just the short form. Give me the full form, and we have already talked about it. So I'm just going to count 1, 2, and 3. The first ones to give me the right answer, you get credit coupons from me, from AWS. And the right answer is obviously Amazon Virtual Private Cloud that we just saw. Now, there is the second principle, that is implement a strong identity foundation. That is, how do you access the AWS account resources? Now, there are two different people, right? One is you, who's creating resources in AWS and want to access AWS. And the other is the persona that is accessing your applications. We're not talking about that now. We are only talking about securing your AWS account resources. There is a service called as AWS Identity and Access Management. So identity means authentication, and who are you authenticating? That we'll see. And there is access is authorization. So authentication or identity is two types: human identities, that is us humans, and machine identities, that is any resources in AWS trying to access each other. Those are called as machine identities. Could be some better name, but let's go with machine identities. And in authorization, you write a flexible permission language, and JSON or YAML based on whatever you choose. But for example, in this, it's very simple. There are 3 things you mentioned. What is it allowed or denied? What is the action that is allowed or denied? And on what resource it is allowed or denied. So if you see this sample example, here what it means is you're allowed to take all the actions on an EC2 resource, all EC2 based actions on all resources. Okay, asterisk means all. Everyone knows that. So these are the simple policies that you can write. You can create a user, you can create a role, you can create a group of people like administrators and developers or something like that. Assign these policies to these identities, and you can define these permissions in the AWS cloud. So for example, if I'm a user, then I would have some kind of policies attached to me. I could be an administrator. I could have full access to everything in the cloud. I could have access to something. I could have access to a region. I could have access to, let's say, a production environment or production VPC only, or I have access to just one subnet. You can do different things there. So as a human, I can log into AWS cloud using the IAM user. Not a best practice, but a lot of people still do that. But make sure you have something. Okay, we'll talk about that. Then you could have people into different groups. This is a best practice. Don't give everyone access, or don't share that one IAM user or one identity. Would you create one Gmail account and share it with 10 other people? Would you give your access to someone else? Similarly, don't do that with AWS. Create different users, give them different permissions. Are these administrators? Are these developers? Are these database people? Give them different permissions and let them access the cloud in that way. So if tomorrow, and this has happened, let me tell you a story. This has happened with a customer when an employee who had access to AWS account had a grudge. He was terminated from the company. And when he was terminated, with that grudge, he went and deleted everything that they had in the AWS cloud. And this customer came and said, hey, this guy has deleted everything. What do I do? And when we asked, do you have a separate user ID for this person? They said, no, everyone was just using the same administrator user. And if we delete that, then everyone loses access to it. And we were like, how can you do that? You should have separate ID access to all these different people and categorize them. The best is to add it to your corporate directory. You can have federation. You can have SAML-based templates or Active Directory or something in your organization, right? Connect AWS to that. Because what happens is, in your organization, you have something like employee lifecycle policies, right? If I leave AWS tomorrow, I lose access to everything internal of AWS, right? Including the AWS account. That is how you should think about it. You should use these corporate directories or identities that you already have and connect that. Don't have to create anything in AWS. Then you also create something like temporary credentials for your machine identities. I'll try to show that quickly if I have time on how you can create these and how you can use these. So let's look at one of them. So what I've done is here I have added, where is my mouse again? Sorry, it's not fun to do this, but okay, so let's check one of these virtual machines. Okay, let me check this virtual machine. As of now, it has security. I have an IAM role that is called as this. So let me do this. Let me go and create a new role. And this new role, what I will do is, okay, it's taking a while. I'll just go and say create a new role for EC2. So either it could be EC2 or it could be some other account, or it could be any OpenID SAML based providers that you have. I want to use it for EC2, and I would say next. And as a policy, there is a service called as S3. Now, S3 is a storage service that AWS provides. Okay, so this virtual machine that I have, this public virtual machine, should get access to the S3 storage, but not all the access. I don't want it to go and manipulate anything. I don't want the application that is hosted on this virtual machine to go and manipulate everything. I just wanted to have a read-only access to AWS. Okay, so let's go and add this data read-only access. Sorry. So allows EC2 instance to call other services on your behalf. I've just created this role. Let it create this role. Let me show you what happens here. Okay. So I can say AWS S3 LS. I just want to read all the storage buckets or folders that are available in S3. The error is access denied. Okay, so this virtual machine does not have access to access S3. Now I've created this, right? So let me just go and refresh. And what was the name that I used? Data something? Data read-only access. That's the name I use. I created a role, right? Let me just save it. And this successfully replaced the earlier role with this role. Okay. Now let's go and do this command again. And I am able to read that data. Don't need to worry about what kind of data is sitting there. But can you see how instantaneous this is? That instantaneously I provided it permissions and it can get those permissions to do these activities. Now, if you're using multi-cloud, you would know that this is not possible in all the cloud providers. But if you do in AWS, it is so quickly possible to give these permissions, and they are easily rolled into your virtual machines, and your virtual machine can go and access different services. And that's the beauty. If this was an issue that, hey, I gave a wrong, I gave a wrong permission to this virtual machine, I don't want this to have that, I can go ahead and remove it. I can say, I don't want this virtual machine to have any access. This is being compromised. I don't want it to have any access. I just have to say, hey, remove it. And you should confirm, do you want to remove it? I removed everything. And if I run the command again, it's again going to say unable to locate credentials, because it doesn't have any credentials now. It doesn't have the role which has the credentials to access these the AWS cloud. So what are temporary credentials? Roles give you something called as temporary credentials, which are access keys and secret keys that you can use to access the AWS resources. So if you want to role for non-human processes, use that. For web and identity, you use this. So I'm just going to skip through most of this. This is important. Use strong sign-in mechanisms. Use MFA, multi-factor authentication. We do that with our banking, right? We add OTPs. Same thing, use that with AWS. Use password policies, strong password policies. Don't let people add passwords like password 123, which is very bad. Add strong password policies, make people add and rotate their credentials regularly. This is an anti-pattern that in AWS, a lot of people just create an account and dump everything, and they may create different VPCs, maybe not. They also don't know if tomorrow there's an audit, they don't know who has access to that database. Everyone has access to that database. Everyone has access to all confidential information. If you get stuck in an audit, this is a very painful problem. So if you're starting with AWS, or if you are already into AWS, make sure you have these different guardrails placed so that you know who has access to what. You can also create different AWS accounts and have people access different AWS accounts. There could be a prod environment into a different account, a dev in different account itself. So not everyone gets access to prod. If you don't want to create different accounts, at least create different virtual private clouds and create that logical isolation and give permissions only to those different resources. So these are some of the principles that you should follow, that you need to have a centralized identity provider, use different user groups attributes, use MFA, use strong password, use temporary credentials, rotate them frequently. Don't set some password and then forget about it for a year and then get into issues. If you're storing secrets, store them securely. Grant least privileges. Not everyone, like I gave read-only access. Don't give full access to everyone and then worry about what do I do. Everyone has access to everything, and if something goes wrong, you will keep finding who is doing what. Define permissions, guardrails, and of course, establish emergency access process. Have an IAM user or a role that you create that no one uses and that is available with maybe a CATO or a CXO of your company. If someone gets access to your AWS account, you can then get an emergency access to AWS. Don't worry, our teams will always help, but you should always have some kind of emergency access as well. So get ready to type in some answers. What does IAM stand for? And I did give that in the slide. So quickly, I'll just hold 3 seconds. 1, 2, and 3. IAM stands for AWS Identity and Access Management. Okay, if you have given a right answer, just give me a screenshot. So these are the quick design principles. If I want to, I can talk on days, nights about these different things, but it's not possible in an hour, and you may also have been overloaded right now with so much of information. So these are few design principles to follow. Apply security at all layers. Implement a strong identity foundation. Don't create one user, one role for everything. Automate your security best practices. There are a lot of different ways that you can automate these security best practices in AWS. Hope I will have another session somewhere and I will let you know how to do that. Protect data at rest, data in transit. You should have some data classification mechanisms. You should know what data is public, what is confidential, what is private, who can access what kind of data. You can easily do that in the AWS cloud as well. Enable traceability. You should know how your requests are moving in the cloud, how what kind of logs are being collected, what kind of metrics are being collected. Enable that so you have more visibility. In AWS, you have services like CloudTrail, where you can know what API actions were caused by which user. And that's why if you have one user doing all the activities, if someone is a fraud, you will never know who did that fraud with you. So having these separations help. Prepare for different security events. You can have runbooks, you can have playbooks. The well-architected best practice, which I will show you in the next slide, has all the information on how you can create these playbooks. So to wrap up, these are different categories that you can have in AWS. We just talk about 1 or 2 services maybe, but there's a lot more that you can discuss on AWS. There are many very different resources to help you learn. First is there is a specialty certification on the AWS platform. So you can, if you are a security specialist, please do sign up for it, learn for it. That's an easiest way to learn more and certify yourself. The next is there are different things, like AWS has everything from documents to training, from in-house training to third-party training. The first thing, if you are new to AWS and you're new to security in AWS, check out the ramp up guide. This should be your first place to start with. This is an easiest thing I can tell you. How do you start with AWS in security? Check out the ramp up guide. There are ramp up guides for everyone, for developers to architects to different personas. Or if you're in machine learning, there's a ramp up guide. Check that out. That should be your first place to start. Okay. Then AWS user groups. Do check out our user groups. Today, one of our user group. Okay, my mouse again stuck. One of our user group, that is Kochi, is a community partner for this event. So do check out. If you are based out of Kerala and you do want to sign up, please do sign up for our user groups. We do a lot more sessions and we do a lot of fun items as well. Then the second thing is check out Reskill. Reskill is a community driven platform. This is not something that AWS has. This is all by the community itself. A lot of fun quizzes, a lot of vouchers to win, a lot of items to win if you learn and keep building. So, a lot of rewards in this platform. If you have to learn about security in the cloud, then check out AWS Well-Architected. If you want to know how AWS secures these things, does AWS has any proof? Hey, I cannot go to your data centers. Does your data center have the security? Yes, we do. We have documents to prove for that. So you can find a lot of information in the AWS artifact and cloud compliance documentation. There is also something called as a well architected tool, out of which I picked up these design principles. There are few labs. If you're interested to do some basic labs to understand how do I do these items in AWS, do check out the well architected labs. These are very good ways to start with AWS hands-on experience. Then there's a lot of information I already mentioned of artifact and compliance. There is a lot of documentation. There is specific security blogs and bulletins that AWS releases as well. So you can check those out and sign up for those. Don't worry about all the links that I showed you. They are available on SlideShare. So just go to SlideShare, Rohini and Conquer, and you should be able to access all this data. I've talked a lot. So I'm just going to take a sip of water and I'm going to ask Meera to come online and see if we have any questions from the audience.
Thank you, Rohini. So we are now open to the Q&A. Please put in your queries. We will be responding. Okay, we have a question now. How can I ensure the data localization requirements in AWS?
So, okay. So first of all, there is a region in AWS. So if you're talking about India in general, we do have a region in AWS in India that is based out of Mumbai. So a lot of our financial customers who have to have data localization, right? They are hosting that data in this Mumbai region. Now, if there is additional information that you need as to, okay, what do I get help from? There are a lot of our partners who help a lot of our customers to meet that compliance requirements that they would have. If you have any such requirements, just hit me on LinkedIn. I will try and get you connected to some of our internal teams who do this day in, day out with a lot of our customers. So they can definitely help you out with this. Just ping me on LinkedIn. Just direct message. It's fine.
Okay,
Implementation
next
of Kubernetes.
next question is, can you tell me about the implementation of Kubernetes security on AWS?
Interesting. Okay, so I did talk about containers. Okay, where is this? Okay, so I did talk about containers in the beginning. Well, the topic is a little bit big. 1 second. So I did talk about containers, and this container services, this actually taps into the service called as Elastic Kubernetes service. So EKS is one of our managed services that you can use on the AWS platform, and in that case, it takes care of a lot of security related aspects in on its own. For example, if you're using EKS and you're just using the master node replication, then AWS takes care of how to secure that information, how to secure the information that you have in etcd. So it takes care of all of these things. Now I cannot tell you about that because that is a little bit internals. But if you're hosting Kubernetes by yourself on the AWS platform, then you would fit into this category where you will have to take care of the operating system, like how do you do patching, what do you do server hardening, all of this details you will have to take care of. If it is something that AWS takes care of, then it is something that AWS will constantly keep doing. I think there should be more information somewhere. If I find it, definitely just hit me on LinkedIn. I will definitely send it across to you if that helps you. Ooh, some people. I want to enforce MFA for all my users, but some of them are service accounts. Service accounts. Interesting. Well, can you explain a little bit of what do you mean by service accounts? Maybe in the chat. But yes, you can enforce IAM MFA. Sorry, I may have typed it like that. Where is my mouse? My mouse keeps dancing. It's all StreamYard. Okay, it's back. So you can enforce MFA. So if you see this, there are multiple articles on how you can enforce MFA. Can you share my screen? Sorry, I thought my screen was shared. You can enforce MFA for all your IAM users that are using AWS. So you have, if they don't have MFA and they are using the services, then they will be given, forbidden access kind of error. So you can find a lot of tutorials on how do you enforce that. If they want, they can go ahead, enforce MFA, and then they can come in and join. So you can do this. I may need a little bit more information on what do you mean by services, but if you have something to talk detailed, please feel free to ping me. People did answer. Okay.
Okay, so it's late and we have it's time for us to wind up. Yeah. So thank you, Rohini. That was a very wonderful session, and it was really very informative. And we are very grateful for that. And with your demos and your ideas, and also your expertise. So, on behalf of HackPay, I extend our sincere thanks to you for being with us today.
Thank you. Thank you so much. Thank you for the opportunity. Thank you, everyone. Good night.
Thanks to all who tuned in today. So, if you have any additional queries, you can reach out to Rohini through her Twitter and LinkedIn handles. And also, we have so many interesting topics on the way. So, please tune into our social media handles for more details. See you all again. So, stay safe and thank you.